All right, section 11.5, we're multiplying and dividing rational expressions. So those expressions that basically are fractions that have polynomials in them, we are going to multiply two of them together or divide two of them. Remember, if we're multiplying, we can multiply straight across, multiply the numerator times the numerator, denominator times the denominator. Dividing, when we're dealing with fractions, we actually multiply the reciprocal of the divisor, right? So whatever we're dividing by, if we flip it over and multiply, it's the same thing as division. And then we can also simplify the fraction just like we would with all numeric fractions. So 7n to the fifth over 5n squared times 10n to the third over 14n. So one thing we can do, I want to kind of show you here, and before we get to a bunch of variables that are a little more complicated. But if I look at 7n to the fifth over 5n squared and 10n to the third over 14n, multiplying these two fractions. But if I look at the numerator here, 7n to the fifth, and the denominator over here, 14n, 7 and 14, they can actually simplify, right? 7 divided by 14, or 7 goes into 14 two times, right? So I can cancel out the 7 and the 14, and that becomes 1 and 2. 7 over 14 is 1/2. N to the fifth, and this n doesn't have a number, so we assume it's a 1. So n to the fifth over n to the first, that 1 would cancel out, and subtract 1 from the 5 would give us 4. If we look at the other numerator with its product denominator, we have 10 and 5. So 10 is divided by 5 to be 2. 5 cancels out, becomes a 1. And n to the third and n to the second. So 3 minus 2 is going to give us 1 here. So all of this simplifies before we even multiply. We got n to the fourth over 1 times 2n over 2, which we can multiply straight across now. That's an n to the 1, so n to the fourth times 2, n to the 1, n to the first. Add the exponents. 2 n to the fifth, 1 times 2 on the bottom, gives us 2. Of course, 2 over 2, cancel each other out. And that all simplifies to n to the fifth. Which, with these numbers, we could have multiplied straight across and then simplified. But I'm trying to show you that in some cases we can simplify them before we do the multiplication, which is really beneficial when we start getting more complicated terms in those fractions and those rational expressions. So let's start with this one here, y minus 5 over 3y minus 3y squared times 2y squared over y squared minus 6y plus 5. So I'm just going to rewrite that. Y minus 5, can't do anything with that really. There's no common term in there. 3y minus 3y squared. So these two terms, we can actually pull a 3 out of both terms and a y, right? Both terms have a 3 and a y. So I pull 3y out of there. then what's going to be left, if I pull 3y, 1 times 3y equals 3y. And if I pull 3y out of 3y squared, that's just going to give us y. So 3 times 1 minus y, 3y times 1 minus y in the denominator. All right, then 2y squared, not much we can do with that. Y squared minus 6y plus 5. All right, that's a quadratic. We can't factor one term out of all of them. So we see if we can factor the whole thing. So no term in front of the y, so we don't have to do the ABC method. We just look at factors of the last term, which is 5. It's minus plus, so we're going to do 2 negatives. And what multiplies together to equal 5? There's only one set of numbers, 1 and 5, right? So if I add those together, that gives me the negative 6 that I need in the middle. So that factors to y minus 1, y minus 5. So y minus 1 times y minus 5. Y minus 5 on the top there cancels out the one that's on the bottom on the other side. So now we just have 1 on the top. So 1 times 2y squared is 2y squared. And then everything else, we have 3y times 1 minus y and y minus 1. Now when you look at this, you should recognize that 1 minus y and y minus 1 look really close to the same, but they're not the same, because this is 1 minus y, y minus 1, the y is positive here, it's negative here. The 1 is negative here, it's positive here. But we could get those to be the same thing if we factored a negative 1 out here, which just changes the signs. So if I brought a negative 1 out, so looking at 3y, if I pull a negative 1 out, I can switch 1 minus y to y minus 1. Minus 1. So now we have two of them that are the same thing. That's under 2y squared. We can look at it as 2y squared over negative 3y now, and y minus 2, or y minus 1 is squared because we've got 2 of them. Now we can look here, we have 2 over 3, which doesn't simplify, y squared over y, that y will cancel out, and that one's going to become a 1. So we're going to have 2y over negative 3 y minus 1 squared. And that's as far as we can simplify that one. All right, so the next one, 2x plus 1 over 2x squared minus x minus 3 times 2x minus 3. So 2x minus 3 could be 2x minus 3 over 1. So we would multiply straight across the top, straight across the bottom. But if we can, we want to simplify. And so we're going to look at 2x squared minus x minus 3 and see if that'll factor. because everything else is in binomials. This is a quadratic, so if we can factor it, make it simpler, then we will. So we have a number in front of the x squared, which is our a is 2, b is -1, and c is -3. So in this case, we need to do the a times c method. So 2 times -3 gives us -6. And we're looking for factors of -6 that will equal -1, which -3 and +2, if we add those together, equal -1. So take those. Remember, we're going to build them into fractions. We're going to have -3 over the a term, which is 2, and 2 over the a term, which is 2. Simplify if we can. -3/2 doesn't simplify. 2 over 2 simplifies to 1 over 2. So our binomials become 2x minus 3. Right? Denominator in front of the x, numerator follows the x, and then 2 over 2 should reduce to 1 over 1, not 1 over 2. And so 1 in front of the x, denominator in front of the x, followed by the numerator, plus 1. So here we're looking at 2x plus 1 over the factored form, which is 2x minus 3 times x plus 1 times 2x minus 3 over 1. 2x minus 3 and 2x minus 3 cancel out, which gives us 2x plus 1 over x plus 1. And even though it looks like we have x plus 1 and x plus 1, those can't cancel because this has a 2 in front of it. So that's as far as that one will go. All right, n minus 2 over 2n divided by n minus 2 over n plus 5. Remember that dividing, we flip it, change, keep it, change it, flip it. So keep the original first fraction, n minus 2 over 2n. Change the symbol to multiplication. And we're multiplying by the reciprocal. N plus 5 over n minus 2. And now when we look at that, we have n minus 2 on the top, n minus 2 on the bottom. Multiply across, we get n plus 5 over 2n. The next one, 5x squared minus 20x over x plus 5 divided by x minus 4. Remember, that's like x minus 4 over 1. Factor what we can, so anytime we see a square, we want to factor it. Or we see a bunch of big numbers, we want to factor those if we can. 5x squared minus 20x. They both have an x. And 5 and 20, or 20 and 5, both divide by 5. So if I pull the 5 out and an x out, since both terms have an x, 5x squared divided by 5x would just leave me with x, and 20x divided by 5x would give me a 4. So now I'm looking at 5x times x minus 4 over x plus 5 divided by x minus 4 over 1. So dividing, it's multiplying by the reciprocal. So keep it, change it, flip it. 5x times x minus 4 over x plus 5 is going to equal 1 over, or not equals, multiply, changing division to multiply. x minus 4. Now we have an x minus 4 on the bottom and the top. Cancel each other out. Gives us 5x over x plus 5. And that is multiplying and dividing rational expressions, section 11.5.